recording. Yeah. Okay, so what do we need to do for this catwalk exercise? So the cat walks, let's just add some comments here. Can do it like this, I guess. So 1, cat walks from left to center. 2, cat pauses and dances. 3, cat walks from center to right edge. 4, go to step 1, right? Or repeat, let's say repeat above steps. Yeah, makes sense?
Yes.
Okay. So let's deal with step number 1 first and not worry about the other steps. So I'm going to create a function and I'm going to call it walk. Walk. And this walk function is going to take 2 parameters. It's going to take start pos, so where is the position where the walking should start, and stop pos, where should this walking stop. Yeah? Then I'm going to use a variable in here which will represent the current position of the cat. Yeah, so I'm going to call it position, and I'm going to initialize it with the start position. So we'll start walking at this start position. Then there are 2 ways to let the cat walk. One is using set interval, and the other one is using set timeout. But then we need to call set timeout repeatedly until we get the stop position. So I think the easiest way to do this is using set interval, and then we just stop the interval when the cat has reached the stop position. Does that make sense? Yeah. So let's say set interval. Yeah, and set interval takes a callback function, and it takes a value for the interval time. So the cat needs to walk, if I remember correctly, it needs to walk every 50 milliseconds.
50, yeah.
Yeah, 50 milliseconds. Okay. So what? How can we? So remember that in the index.html file we have this image already. So we can get that image using a query selector, right? No issue, right? So how can we make this cat walk? Well, we set the image style left. We can use a backticks, and then need to set it as pixels. Yeah, and then we can increment the position by the step in pixels, which is 10. So every step the cat moves 10 pixels. And then if we have reached the stop position, so if position is greater or equal than stop position, or well, stop walk I called it, but I think stop pos was the idea. stop pos, stop position. Then, well, we need to clear the interval. But to clear the interval, we need to save the return value from setInterval into a variable. So that can be a const. Okay, I think that's it. So let's create some variables. So we need to, what is the start position of the cat? So what we can do is, well, we could say with const, let me just have a peek here. Okay, we could say start pos. We could let it start at position 0, left edge of the screen, and we could let it stop at the, well, who can give a suggestion where it should stop? I didn't hear that.
Alex, I think Alex, you have problems with the microphone.
Yeah.
I think we need to have the width of the screen, maybe minus the width of the cat divided by 2.
Okay, so that would be something like window dot inner width. So that's the width of the screen, right?
Yeah, yeah.
And then minus what?
The width of the image, the cat itself.
Image dot width, I think, right?
Yeah, yeah.
And then that's divided by 2?
Yes.
So, okay. Because the position of the cat is equal to the left position of the cat, right? So yes. You guys already did this exercise, so you probably already have some idea of what the code should look like, or at least how the positioning works. So we can now call our walk function and use the start pos and the end pos values, and get rid of the to do. And here we have some initial code. So let's see how this works, or whether it works. So I'm going to open it in the live server, and I'll drag this screen over here where you can see it. Okay, and I probably need to reload because I maximized the screen. Yeah. Okay, it doesn't. Let's see. It doesn't work. Oh, of course we're not walking to the end of the screen. We're working to the center of the screen, right? Yeah. So that seems to be the center of the screen. Okay. So I'll move this away for now. Okay. Now, how can we use? No, let's put it another way. I would like to be notified when the cat has reached the center. Yeah, and that's where the promise comes in handy. Yeah. So what we're going to do is we're going to wrap this function here into a promise. Yeah. So walk will return. Currently walk doesn't return anything, it returns undefined. We're going to let it return a promise so that we know when the cat has reached the middle of the screen, then the promise resolves. Yeah. So I'm going to create a promise, Actually, I'm going to return that promise. Return new promise. And a promise takes a callback function which is in itself, which takes two parameters, resolve and reject. Like this. And I'm going to wrap all this stuff, or place all this stuff inside that promise. Right? And I want to resolve this promise when the cat has finished walking. And that's over here, right? Here, I'm going to resolve the promise. And I'm only interested in when the walking has finished. I'm not interested in any return value or any resolve value here. Huh? I'm only interested here when the cat has finished walking. Now with this code, I now can tell inside the cat walk function when the cat has reached the center of the screen. So what I can now do is can say, for instance, then, and I can have some function in here. I could, for instance, say console log center reached. So I expect this console log to appear when the cat has reached the center.
I have a tiny question over here. What does the function interval ID purpose here?
Okay, so I need to be able to clear this interval when the cat has reached the center of the screen. Yeah, and for that reason I need to specify which interval I need to clear, because I could have multiple set interval timers running, and I need to indicate I want to clear this one. So the set interval function returns a number, I think it's a number, yeah, which you can use to indicate which interval you want to clear.
So the interval means the distance that the cat has been walked.
No. The interval means it is an identifier for the interval timer.
Oh, okay.
Yeah, it identifies the timer. It has nothing to do with the cat. It has only to do with the set interval itself. It identifies the timer so that I can specify now in clear interval, hey, please clear this interval timer.
Ah, okay. Yeah.
Yeah? Okay, now let's see. Let's go back to the cat, and now let's go back to the console. Well, let's open up the console. Do I have the console log here? Where is it? Here. So let's refresh the page. Hey, cat has reached the center. Yeah. Now with that knowledge, it now becomes, in my view, almost that easy to complete this exercise, because instead of doing this console logging, we could walk again. Yeah, we could say then walk, or actually we should say return, I think. Let me just see. No, we don't need to return that. We could say
function walk again. Yeah.
We could walk again. And now we want to we could say here, this is actually the center pos, right? Center pos. We wanted to walk from the start pos to the center pos, and then let's say the stop pos is the right hand side of the screen. So when it's walked up to the center, we wanted to walk it from the center to the stop pos. Or we could even add another then here. Oh, wait a minute, not then. We could say, we could add our console log here. Does this code make sense? Questions here so
Yes.
far?
Yeah, makes sense. Yeah, and it's easier.
Yeah. So we walk from the start position to the center. Then we could say, hey, dance here, please. We're not doing that yet, but yeah. And then we walk from the center to the right. Let's see what happens here. Okay, let's refresh the page to make sure. Okay. Center reached, dance here, and then we go to the right hand edge of the screen. Questions so far? Does it make sense?
Yes, it does.
Okay, so let's now write a function called dance, function dance. And here I want your input. So dance, what do we need to do here? Let's first wrap this into make sure that we return a promise. Resolve, reject.
We need to put a new promise, no? The keyword new.
Thank you. Okay.
And
So what do we do
should-
here?
We should set interval for 5 seconds, I guess.
Yeah, so let me just copy this one and constant here. Oh, wait a minute. No. I want to have the whole constant. So this is the URL for the dancing cat. So, okay. What do we do here?
I guess like in the resolve callback, the handler here, it's going to handle loading the new image and waiting for the certain time. And the reject callback function, it's going to handle the process like the time is finished for dancing, so we walk again.
Okay. So, so first we need to switch the image, right? We need to switch the image from the walking cat to the dancing cat.
Yeah.
Yeah. So, so I could just save the current image. The current image is the walking cat. So we could do something like this: saved src equals the current image of the current source of the image, and then we switch to the image source equals this dancing cat URL. Yeah, that's what we do here. And then after, what was it, 5 seconds, I think, we need to switch back the original image.
Yeah, after 5 seconds, switch back the original image and
Yeah.
then make it walk to the last of the width
Right.
of the contour. Yeah.
So we'll use the set timeout, I guess, right? You guys have also used the set a timeout. Okay. Like this, 5 seconds. So after 5 seconds, we switch back to the original image. So image.src is our saved image. SRC, or saved SRC. And then we say resolve the promise. Oops, like this. Yeah? And by the way, you can see here we're not rejecting. You can see this is a bit dimmed, which is an indication by VS Code that we're not actually using this variable. See, it's declared, but the value is never read. So actually, we can get rid of this. Since we're not calling it, we might as well get rid of it. Oh yeah, well, as well. Okay. So now, how can we make this cat dance? How do we integrate it into this function or into this chain?
We have to use maybe the chain promises, but here the complicated part.
Just replace the console log with dance, call to dance.
Okay, let's give it a try. Like this, right?
Yeah.
Okay. So we walk, we dance, and we walk. Makes sense, I think.
I think you also have to add a return before dance, right?
Return before dance. But what does dance return? Well, it returns a promise.
Yeah, because you need it for the next dance, right? Or not?
We don't need it.
Okay.
But we can explain it later why we don't need it.
Is it because that we don't pass anything, any result value?
It's, well, we could do this, return, and then we know that dance returns a promise. Yeah. But a then also returns a promise.
Yeah.
Yeah. But in this case, it returns a promise that resolves to undefined. It's like doing return undefined in here. Yeah. So the result value of this promise would be undefined. So basically, we don't need it here because we're not really passing here a value. We're not interested in a return value from dance or from walk. We're only interested when has it finished. Yeah. So to make this completely similar to the other dance, we could also remove the curly braces, and then it would be and the semicolon, and then it would look like this. Walk, dance, walk. Okay. So let's give this a try. Let's reload the page to make sure. Well, it's already dancing. Yeah. But now, of course, it doesn't repeat yet. So how can we make it repeat? Well, we could use, and this is, I guess, not something that you would easily come. Well, I guess you guys have already done this in your exercise. You probably made the recursive call. Yeah, you made a function like, let's say, how did I call it here? I called it loop actually, because that's sort of like what we're doing. We're going to create an arrow function called loop. Yeah, and we're going to put all this stuff in here. Like so. And now we call a function loop, which still doesn't loop, but so we're just calling this function here at the end of this function, and we'll execute this code. That still doesn't make the cat walk again, but let's see what happens. So this still works, right? It dances. Okay. So we're nearly there. How now can we make this cat walk again?
I think by calling the first function.
Which function is that?
I think walk function.
Excuse me, I didn't get that.
The first one is from the left to the center.
Yeah. Anyone else an idea? Well, we didn't create this function for nothing, right? There was a purpose for this function.
Can we add another done at line 47?
Mm-hmm. Oh.
After that, we can make cat position again 0.
A cat position against 0, but the position is over here, right? The cat walks from start pos to stop pos. Yeah, and start pos is 0. Well, here it is 0. We've initialized it to 0.
What if we used an infinite loop, like we did while true, and we call the loop function?
Yeah.
Yes, you can call the loop itself over here.
Okay, so here a while.
Yeah.
Yeah.
Would that work?
Okay. Well, let's give it a try. So it would be something like while and then what? While true or something? While forever?
Yeah, because we want it always to repeat if we are having it. There is no condition we have in the exercise.
Let's see if that works. Something like this, right? I hope this doesn't screw up my browser, but let's see. I don't know what happens. Where are we? Over here. Okay, let's reload the page. Or you can already see my browser is having difficulties. I think it's.
Now we have to use it then, because we need to only call the loop after the first completion.
Yeah. So my browser is hanging here. So I'm going to. Oh, can I close it? I'm not even sure. Okay, I have a problem here. So I hope, because I'm also using the browser for our session. Let's see, can I stop this? Okay. Okay, so well, this doesn't work, right? This doesn't work. So another suggestion?
Can we call the loop function inside the loop function itself?
Yes, of course
we can create another then.
Yeah.
Now what?
Calling the loop function again.
Okay. Now let's see if I can open another browser session, because my first browser session is stuck. I hope this works. Let's see. Okay. Now I think we have an error here. Or not. Oh. Try again. Okay. This. I have no idea what's happening now, whether this is because my browser session crashed or not. So let me just remove this for now and see what happens. Okay.
Jim, I think you need to call loop again at the end of the catwalk function.
Ah, thank you. Yeah, somehow it was, I removed it. Yeah, thanks for that, Jonathan. Yeah, so we're calling loop here recursively, but we need to call, we need to kick off this loop by calling loop here.
Yeah.
Oops. Okay, that should hopefully do the trick. Let's see over here. Okay, can remove this breakpoint here, then reload the page. Okay, there we go. Dance. I think this works. And if we look at the code, it's, to me, this makes sense. And to me, this is what I would call an elegant solution. Because we can read here what happens. Walk from the start to the center. Dance. Walk from the center to the right end of the screen, and then start all over again. Yeah? There are a couple of things I would like to improve for readability and maintainability. So for one thing, I use numbers here. And when I see a number, I always have to think, what does this number mean? Numbers like this in code are often called magic numbers. Because when you see the number, you always have to think, okay, what's that number doing here? What does it represent? So what we normally do is we create variables for these numbers that describe what the numbers mean. And I'm going to copy them straight away here and move them over here. So we have, so the number 10 is the step size in pixels. So now I don't have to map in my mind the number 10, oh, that is the step size in pixels, because I've made it explicit. Same here. This is the step interval in milliseconds. Step interval, yeah. And then we have another magic number, is the dance time in milliseconds. Oops. Okay. Now, and the last thing is this image here. I'm getting it when the file loads. Yeah, but if depending on where you place the script tag in your HTML, that image element may not yet be rendered in the page. So the best thing is to get this image value when you load the page, and we load the page when we execute the catwalk function. So it's best to get the image over here. Now, of course, if we get the image over here, then I can't access it over here. So it's, what we can do is we can pass the image as a parameter here. Yeah, and over here. And now, every time we call these functions, we also need to pass the image in here. So over here, image, this image variable, dance, image, and walk, image. Okay, let's see if it still works, and then we can review the code. Okay, it doesn't work, I guess, or what? Okay, cannot access image before initialization at line 41. This is very small for you. Oh, actually I can increase this probably. Yeah. So line 41, we have a bug. Line 41, because here it says, see here we're trying to reference image, but we've defined it over here. So I need to move this a bit up, like this. Okay. Where are we now? Where's my browser? It's over here. It's already dancing. Okay.
So, I'm sorry, Jim, but is this kind of like the JavaScript standard style, like the improvement that you're doing? Like, is it like kind of rule in the job day?
Yeah, well, you probably also all have working exercises, right? In week one of the browsers, more or less.
Yeah.
So, is working code good enough? That's really the question. If you have something working, is it good enough? Well, it depends, because code will have a long life, or can have a long life. You may need to revise your code or maintain your code, or somebody else needs to maintain your code perhaps in a year's time. So your code also needs to be maintainable. Now, if you go back to the exercise and look at your code and then compare it to this code, you probably have to think hard again, if you look at your original exercise in the way you did it, how it works, because it's complicated. The fact that time makes code complicated. So in my view, code is never finished. You can always, well, not always, but most of the time you can make improvements to your code. Yeah, and if you have the time, you should do that. Because it will make maintenance of your code so much easier.
Absolutely agree. But like the question is it's not like, is this kind of like the standard guide? Because in our repository, like for the week, the readings, there is style guidelines for the JavaScript, how you should write the JavaScript, in what style. If you know what I mean, like.
Can you give an example of? I'm not sure if I.
It's fine. I'm gonna send it in the Slack.
Okay. So let's then review this code again. Yeah. So we started off with this function just to let the cat walk from some start position to some stop position. Yeah, and when the cat has completed that walk, we stop the walk and we resolve the promise. Yeah. So we could let the cat walk from the start position to the center position. Yeah, and then secondly, we added this one. We could let it walk from the center position to the stop position. And then we added the dance in between. And finally, we let it repeat itself. Questions so far?
Yes, Jim, please. I have a question. Like here in our scenario, here in our code, it's not like a chained promises, right? Because we are not returning promises to another then. It's not chained promises.
Well, these promises are chained, right? This is a chain.
So it's a chained promises here.
Yeah. So the only thing that we are interested in these promises is that they have been resolved. We have no reason or to let the promise resolve a value, right? We don't. I mean, this doesn't make sense, right? The only reason that we have promises here is to get notified when the event or the action that we are monitoring with the promise has finished, has completed, has been resolved.
Okay.
Yeah.
I want to ask a question.
Yeah.
Why you make the last promise not then, and we give it loop function? After this function, we call loop again. Why we did like that?
This one. You mean why we do this?
Yeah, this and this. Yeah.
Yeah.
The last then.
We saw when I forgot to put this in that nothing happened because this is only a function definition.
So why nothing happened? And I put the last then with loop. I call the loop again. Why nothing happened here?
Okay, let me change this this arrow function in just a regular function. Maybe that makes sense then.
Yeah.
So I've only defined a function. I've not called the function.
Yeah.
So if I don't call this function, and you can already see it's grayed out because it says loop is declared, but its value is never used.
Yeah.
So if I don't call this function, nothing will happen.
Although I used it at the last then.
Yeah, but this loop, this then is only executed when I call this function. I need to call this function to start off.
Yeah, firstly, yeah. Yeah, exactly, yeah.
Yeah, if I never call this function, it's just defined, but nothing happens.
Yeah, exactly.
Yeah?
Yeah. Thank you.
Okay, I'll move this back to this. Other questions about this?
Yes, I have a question about the image. Why you prefer to use it as parameters in these functions rather than using it as a global variable?
Okay, let's do that. Let's remove this from here. Put it over here. Okay, and then we can get rid of this. We can get rid of this. And we can get rid of this here. Here. And here. Okay. Now let's go back to our browser window. So this still works, right? No problem.
Yes, I know, but I mean, you prefer to do this instead of this. So what is yeah.
Okay. So now let's make a change in our index.html. You can see here I've loaded the script over here.
Yes.
Now, what you can also do is you can move that script into the header. Here.
Yes.
Let's see if it still works. It stopped working.
Okay.
Yeah.
And why that?
It says here, uncaught type error, cannot read property of null, reading width at catwalk line 43. So let's look at line 43. Line 43. Here. You can see it complains about this image. This image is null. Or actually, we can probably show that also here in the code. If you go here. Here, see, image width, image. Can I see what image is? Or I can put a breakpoint in here. Yeah, like this. And now we can look at image if it runs. Now, why doesn't it stop at this breakpoint? I don't know.
Maybe here because also the image tag not created yet because we went to the JavaScript before we.
Oh, okay. Yeah, here. Yeah, probably. Yeah. Okay. So let's see. Can I step over this function here? So image is null. See, image is null.
Yes.
Yeah. So and the problem is if we look here in in the elements, you can see we have a head, but we still have an empty body. The body, the browser hasn't finished the body yet.
Ah, okay, yes.
Yeah, so the image isn't there. So that's why I prefer to have this image as we had it. So we move it into here, because we know when this catwalk function starts, we have already loaded the page, because we're using add event listener here. Yeah, so now we can use image here. We're passing it as a parameter. And then we need to add image here and image here. Let's see, is that complete? Image. Oh, we don't need the extra comma here. Okay, let's go back to the browser and see if it has solved the problem. Of course, we're still somewhere in the sources, in the breakpoint, so let's get rid of the breakpoint and reload. Let's get rid of the breakpoint, I said.
Okay, perfect. Thank you.
Yeah. Okay. Now we spent a bit of much time on this, but I'm going to complete this anyway. Now, just as an exercise, I want to see how we can do this with callbacks. Yeah, and see if we can create a callback hell. It's not that difficult. So instead of promises, we're going to use callbacks. So the way I'm doing that is I'm adding an extra parameter called CB for callback. So I expect callback to be a function. And I'm going to remove the promise. And instead of resolve, I'm going to call the callback. So the callback is called when the cat has finished walking to the stop position. Here's same thing. I'm going to add image and then callback. And instead of resolve, I'm going to call the callback. Yeah. Now over here, we have, so walk now takes 4 parameters: image, start pos, stop pos, and callback. So walk takes here a function which should dance, and this dance function takes another callback, and that callback should walk from the center position to the stop position. Yeah, and the walk function takes a callback, and that callback should call the loop. So we get rid of all the dance. Now, would this still work? I don't know. Let's give it a try. Okay. So this is what you could call callback hell, because it's a callback and a callback and a callback and a callback. Now you could, I guess, because Prettier makes a bit of a mess of this, you could say, okay, Prettier, please ignore this next statement and don't reformat it, and let me reformat it by hand to make it at least looks a bit more readable. So I would do it like this, I guess. So I would have it over here, and then I would call dance, and then I could do it like like this, like this, and like this, something like this. Okay, so at least it looks a bit better, but it's still callback hell. It works, but perhaps not that readable and not that maintainable. Okay, so I spent a lot of time on this, but I think it may already answer some of the questions you had in the Slack channel.
Yeah,
Questions?
it deserves, yeah.
Questions so far?
Yeah, could you probably put this code in the Slack so I can study it later on, or?
I'm going to give you a link to this complete repo.
Okay. Yeah. Thank you so much. Yeah.
Okay. So I did this live coding, but there are ready-made versions in the callback. Yeah. So this is the callbacks version, and there's the promises version here. So you can study that in your own time. All right.
Yeah. Thank you so much.
Okay. It's now almost. What shall we do? Shall we have a break now? 10-minute break.
Yeah.
Okay, so 10 to, what is it, 10 to, or 20 past 1, we'll start again?
Sure.
Sure.
Okay.
Thank you.
Yeah, talk to you then.
Is my voice clearer now?
Yeah, it's perfect.
Good.
Great.
Okay, I don't know if everybody has returned already, but I think we need to continue. Before leaving this, there's one more thing I think in view of your questions that we could do here is we could resolve to something here. So I suggest that we return as the resolved value the position of the cat, just to see how that would work. Yeah. So instead of just calling resolve without anything, we pass back the position to the caller. And over here we could resolve the string. Okay. I danced. Yeah. Okay. So now our loop could look like this. So now we get the result, right? So we can say result. Yeah, and then we can make this something like this. Okay, like this. We're missing here. And we could say console.log result. So that, let's say here, oh, okay, no, this position. And here, when we dance, we return the promise from dance. Yeah, and that then we got another result. So we console log that result. Yeah, and then we return the result from walk, like this, missing here, like so, I think. Let's see, we have a result here, we have a result here, and then we have a result here from walk. We have a result, and then we console log the result and we loop again. Okay, so now, well, I could return loop here, but it's not really necessary because it just calls the function again. So I don't need to return it actually. I don't need return here. Okay, so now we should look at the console and see what happens. Over here. So let's go to the console. Where is the console? Do we have an error? Because, oh, no. Console. Okay. So here you can see now, because this returns a promise that resolves to a value, we need to return this promise, because if we don't return it, let's see what happens when we don't when we forget to use return. Undefined, undefined. Oh, what's happening here? Let's see. Did I make a mistake here? I said dance, walk. Oh, I don't need this console log result here. Oh, yeah. That, oh, I don't know what's happening here.
I think it makes sense, right? Because you don't return the promise and it just falls through to the next den, right? It doesn't wait for the promise to resolve. That's why you need to return it inside the den.
Oh, yeah, of course.
So this is
I need to return it. Yeah. No, you're right.
Yeah.
That
was what I meant also with my remark beforehand with the return statement.
Yeah, and of course, if I do it like this, it already returns the promise, right?
Right, because it doesn't wait for the return promise to resolve.
Yeah. Okay. So let's restore it as it was, and we don't need to return loop. Okay. So I want to stop this now, I think, because we've already spent too much time on this. Let's go to the questions. And we probably have already answered some of the questions. And Jonathan, if you want to pick up a question anytime. Okay. So here's the question from Mohammed.
Yes.
Hello, my question is, what is the difference between async function and multi-threading? Okay. Any volunteers to answer that question?
Well, I'd just like to say that with multi-threading, I mean, I don't know JavaScript, but I think so, in some language we have the choice. You can enable multi-threading for specific codes, but generally multi-threading is done on the level of the CPU. So the CPU decides which code, assembly code to execute, it looks for code that's independent of each other, and it just schedules it that way, so we don't have any say in that, so it's more on the CPU level, and I think it's something that you have to decide when coding, so in what order you want to execute specific functions, and so it's not really related to each other, I'd say.
Okay, thank you. So JavaScript is not a multi-threaded language, right? It's a single-threaded language. So it can only do one thing at a time, and basically it runs the code from top to bottom, and then it finishes. It runs what is called to completion. But still, we can do multiple things at the same time in the browser, and how should I say that? As I said, the JavaScript engine is single-threaded, but the browser itself, in which the JavaScript engine runs, can do more things in parallel. For instance, it can do it can render the page, and it can do network requests all at the same time. So although the JavaScript engine does one thing at a time, the browser can do multiple things at a time. And the way it works, I guess, perhaps I can use this. Let's see if this works. Yeah, so if you look at this code, and you can see, yeah, it's big enough, I guess. If you look at this code here, there are basically 3 runs of the JavaScript engine. Yeah, the JavaScript engine first runs this console log, then it sets up a timer, it sets up another timer, and it runs this console log, and then this code is finished. Yeah. Then after 1 second, the JavaScript engine starts again. It runs this console log. And then when it's done that, it immediately runs, well, after 2 seconds, I guess. 1 second later, it runs this code. So this the JavaScript engine runs 3 times for this code. One wants to run this code, to run the console log, set up the timer, set up another timer, and run this final console log. Then after 1 second, it runs again, and it only runs this code. Then after another second, because there's delay is 2 seconds, it runs only this code. Yeah, and you can see that if you run this, starting, ending, time at 1, time at 1 and timeout 2. So this is the output from the first run, this is the output of the second run, this is the output of the third run. So the browser basically can do multiple things at a time. It can run these timers internally and notify the JavaScript engine, hey, this timer has occurred. It places it on the event queue, which you have seen, I hope, in the video, and then this code runs. So there are basically 3 tasks. Run this code, then after 1 second there's another task, run this code, and after the third one is run this code. Yeah, and here the run to completion concept is used. So the JavaScript engine runs whatever it can run synchronously. Then when the next event is queued and is current, it runs that event, and it runs that to completion. Yeah, so although the JavaScript engine can do only one thing at a time, the browser can do multiple things at a time, and it will schedule runs for the JavaScript engine to run. Does that make sense?
Yeah, I think that the browser could make a lot of things at the same time.
Yeah.
That what was the thing that confusing me.
Yeah.
Because I know that JavaScript is single threaded. So
yeah.
How come?
Yeah. So the JavaScript engine is single threaded, but the browser is not.
Yeah, exactly. That what was the thing that confusing me. Yeah.
Okay, great.
Thank you.
Okay, so let's see, browser that hosts, it's called hosting, that hosts the JavaScript engine. Is multi-threaded. And can do multiple things. Okay. Yep. Then Danielle, should we always use async and await syntax if possible and only fall back to promise then syntax when necessary, or whether it's more nuanced than that? Well, async and await is actually a topic for next week, but async and await is a fairly recent addition to the JavaScript language. So you can see here, if I move it over here and probably increase the font size a bit. This is from the from Wikipedia, and you can see here in JavaScript version 7, the 7th edition, there is async and await. So that was introduced in 2016. Yeah, and promises was part of ECMAScript ES6 2015. So it's only fairly recent, well, a couple of years ago, that async and await was introduced. Let's see if we still have you guys. Yes. So async and await is an alternative to using the then and the catch. Yeah. You need to know both ways, because you may need to work with older code that uses the then and the catch syntax, or maybe you're working in a team and your project uses then and catch. So you need to know both ways. But if you, I prefer myself for new code to use async and await. Yeah, it makes your code easier.
Yes.
And in fact, we could have so this is actually next week's topic, but we could have a quick look at it, quick peek at our function here. If you want to convert this to async and await and see how that simplifies things, then I guess you could do it like this, and it makes life easier. So first, to use async and await, you have to declare this function as being async. Otherwise, you can't use await. And now we can say here, you can see here, this walk function returns a promise that resolves to the value result. Yeah. So I could say const result 1 equals await walk. So if you don't understand yet what I'm doing here, it's no problem, because we're doing this. This is a next week's topic, but I just want to give a quick flavor. Yeah, and then we can console log result 1. Yeah, and then we can dance also returns a result. And I'm awaiting that result, and put it inside a variable result 2. And then I can console log result 2, and then I can await. So const result 3. That will be 3, and then I console log 3. Now the nice thing about await is that it looks almost like synchronous code. Let's see why. Okay, I need to get rid of this and get rid of this, I guess. Okay, so it looks like almost like synchronous code. Now, what we also can do here is we can now use a simple while loop. We don't need this recursive call anymore. So this is what it would look like with async and await. And let's make sure that it still runs. Let's see, where's my browser? We're here. Here's our cat.
Yes, nice.
Okay.
Yeah, it's much more readable this way.
Okay. Again, don't worry about this if it's completely confusing, because you will revisit this again next week in more detail. Okay. That's I'll fill this in later. So how do we handle existing library packages or functions that uses callbacks, and can we convert these to async and await or promise syntax? Well, I think we already did that, right, with timeout. So we could create a new, let's say, timer. So, or I could have a, let's create a function here called wait. Yeah, and it will take some time to wait, and then we're going to convert set timeout, which uses a callback, right? Set timeout uses a callback. And then then we can specify time. So what we can do is, if we want to run some function when the timeout has happened, we could convert this to a promise. So we return a new promise. And in this case, we only want to resolve. We're not going to reject something. We're only going to resolve. Yeah, and then inside the here, oops, like this. Oh, sorry, like this. And over here, we just resolve. So this set timeout function, which takes a callback, this is the callback, we're converting that now to a promise. So now we can just say wait, let's say 1 second, and then console log something like this. I don't know. Yeah. So we run this. Let's see. I called it timer. Yeah, so after 1 second. So, but yeah, so you can convert a callback or a library function or whatever that takes a callback like this one into a promise by wrapping it inside a promise and returning that promise. Yeah, does that answer your question?
Yeah.
Okay. Okay. Yeah, that was question 2. Do promises always execute after the rest of the stack has been emptied? Rest of the code has been executed. Yeah. So basically, we can have a quick look over here. Let me see. What's over here? Yeah. Let's have a look here. Okay. Here's a quick question here. What will be printed to the console and in what order? So I have here a function called log, which simply console logs the message that is passed as a parameter. And we have log starting. We have a function here in the set timeout, where we log this, set timeout. Then we have a promise, a resolve promise. Ooh, that's this is a lot of stuff here. There's a lot of stuff here. Maybe too much. So let me just get rid of the promise first. So what will be printed? And in what order?
I mean, yeah, like a previous example, right? Starting, ending, and then timeout 1, timeout 2.
Yeah. Okay. So let's run this. So I call this index. Oh, not index, not HTML, of course. Yeah. So again, so there are 3 times that the JavaScript engine runs. This is one from the first run, this is from the second run, and this is from the third run. Now, if we include this whole promise stuff, so this is a way to quickly create a resolved promise. Yeah, and let's get rid of some of these things because otherwise it becomes too complicated. Okay, let's get rid of this for a moment. Let's have a look here. Okay, this is the whole code. So what will be printed?
Okay, this is a bit trickier. Yeah, only doubt is between if the time. I guess the timeouts. If I would guess, I would say like before, and then the promises resolve will be the last. So then 1, then 2 should be those will be the last two statements to print.
Does everyone agree? Or does someone think different?
I think promises before set timeout.
And why do you think that is?
I don't know. Maybe because set time is a browser tool, so it will be the last thing.
Okay. Well, let's give it a try anyway. So can I clear the screen like this? Let's see this. Yeah. Okay.
Yeah.
So first we get the synchronous code, right? This is 1. Then we get the first then, the second then, and then the timeouts.
Okay.
So again, this is 1 run of the JavaScript engine, the second one, a third one, 4th one, and a 5th one. So basically, set timeouts like this are called macro tasks. Macro tasks. Promises are called micro tasks, and micro tasks are always executed or have a higher priority than macro tasks.
Okay.
Yeah?
Okay. Makes sense.
Yeah. So I think in the video that's on YouTube, they only talk about the timeout. They don't talk about promises, I think.
Yeah.
There are actually 2 queues. One is the macro task queue, where the timeout fits, and there's the micro task queue, where the promises fit in.
Okay. Yeah, I didn't try this myself, so that's why I guessed. But yeah, explanation makes sense then.
Is that clear for everybody?
Quick question. Are there any other similar functions like set timeout, which like execute at the end, which you call macro function, right?
Yeah, so basically, there are more functions that work, well, there are more asynchronous functions. Like, for instance, what you'll learn next week is making network requests. When you make a network request, it takes time for the server at the other end to make a response and for the response to travel over the network. So that there will be a delay there, yeah, and that delay is similar to a set timeout delay.
Mm-hmm.
Yeah.
Yeah. Yeah.
So and for instance, when you go in the next module, the Node.js module, you will, for instance, be reading files, and a reading file also takes time. Yeah, so it also comes back as an asynchronous event that you can wait for, and that will also be a macro task. So only the promises are micro tasks.
But those like fetch and those async functions aren't they based on promises?
Yeah, fetch again. That's a topic for next week. But a fetch returns a promise.
Yeah. But it's still considered a macro macro task?
Well, the promise itself is a micro task, but the waiting for the network to respond takes more time. So as soon as the response comes back and the promise is resolved, that the promise itself is regarded as a micro task. Yeah, but of course the network request takes far more time. Okay. Let's see, what else do we have? Loop promises always execute after the rest of the stack as MP. I think we answered that question now, I think, right? Okay, what's the difference between promise all and promise all settled?
Should I take this one, Jim?
Yeah, sure. Go ahead.
Yeah. So, as I understand it, promise.all and promise.all settled they work the same way as long as all the promises resolve successfully, but the behavior is different when one of them rejects. So with promise.all, as soon as one of the input promises rejects, the result or the output promise will reject as well. With promise all settled, it will wait for all the promises to finish, whether they're successful or not, and then return you an array with the successful values and the failed values. Does that make sense? Yeah?
Yeah, it makes sense, yeah.
Okay.
So I think better to use promise.all settled. Make the picture clear to see what's rejected in your code.
Exactly, yeah. So with promise.all, it will only tell you the first one that failed. Promise.all settled will tell you all of them that failed and all the ones that succeeded as well.
So basically it's also a matter of what do you consider success and what do you consider failure. If you say, let's say you're making a bunch of network requests, and basically you say, okay, if one of them fails, I consider all of them failed, because I can't continue if one of them is not settled. Yeah. So then promise all would make sense, because you say, okay, either all are successful, or if one of them is not successful, I don't want to continue. I want to do something else. Okay, but on the other hand, if you say, okay, I don't mind if one of them fails, just tell me, and then I'll deal with it. But let my code continue. Then all settled is useful, and also all settled is a recent addition to the JavaScript language. I think I don't know, 2020 or something. It's not all new. I actually have an example that we can run here. Okay. So here I have a function called wait. It takes two parameters, success or fail, and it takes a delay parameter. And these have default values, these parameters. So if I don't specify these parameters, success or fail will be success, and delay will be 0. Yeah. Let's see. So here I have an example of promise all. Yeah. So I'm creating a promise array of 3 elements, of 3 promises. Wait, wait, and wait. So all those promises, because I haven't specified anything here, will be successful. Because if success, so here if I have timeout, if the promise, this parameter is success, I will resolve it. Yeah, and I will not run reject because I'm returning here from this function. If this parameter is not success, then I will reject the promise. Yeah. So here you can see I have 3 successful promises. I use promise all using this promise array, and then I will print the results. And I will, if there's an error, I will catch the error. So let's run this. I've called it promise all. Okay, node. Okay, so what is the result? It's an array with the resolved values of the 3 promises. Yeah, so they all return success, success, success. Yeah, does that make sense? Yeah? Everybody?
Yeah.
Yes.
Okay.
Yep.
Now we have some code where one of the promises will fail because I've made it fail. I've said, hey, please fail. So this second promise, we expect that to fail. Yeah? And the rest is the same code. See, then result, then catch, blah, 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 blah. So what happens now? Well, can anybody predict what will happen? What will be the result here? What will we do? What will we see in the console?
Probably all of them will fail.
I think with all just the first one, and it's gonna stop with the failed one.
Okay, well, let's give it a try. It only says failed. Yeah, so it only executed this line. So this second promise failed, and it causes the whole promise to fail, to be rejected. So we don't get here, we only get here. And it will print the message of the failed promise. So we don't know which promise failed, we only know one of them failed, or perhaps one or more, I don't know. Yeah, and that causes the whole promise to be rejected. Yeah, and we're not, in this case, we're not interested in which promise failed. We just want to know, well, they didn't all succeed. Now let's look at all settled. We have it over here, I think. Yeah, all settled. Okay, same thing, but now we use all settled. So let's see what happens when, so these promises are all successful. They will all be resolved. So what do we get? We get an array with where each element is an object. And the object indicates whether that promise, whether that status was fulfilled, so successful, resolved, and what the value is that was resolved. Yeah, so we can see all promises were resolved. In this case, it was successful. And then the final one, let's see what happens when one of the promises of the all settled fails. Well, we get this. Oops. Let me do it like this. Where are we? Oh, I can repeat this, I guess. Clear. To make it. So the first promise is successful. The second one was rejected. And the reason is, well, whatever you pass in the reject. And it also prints the stack trace, giving more information about the error location. And then the third promise was successful. Yeah, so all settled. And oh yeah, there's also another thing that I want to point out. You see, with all settled, the promises are you always get a result. So this catch will never execute. You always get a result. But the result itself indicates whether certain promises are resolved or rejected. Is that clear? Does that answer the question?
Yes, clear.
Yeah.
Okay. Let's continue. My question is I don't think we have Christina online today, do we? Or are you there, Christina?
Yeah, I'm here.
Oh, you are.
We have. Chris is down.
Okay. Okay, so I think you were talking about this one. And this is where you got stuck, right?
Yes, this one.
So it says the function job must return a promise object. Well, you already know that to return a promise object, you do something like this, right? Return new promise.
Yeah.
And then probably increase the font size a bit more. And then resolve reject or something like that.
Mm-hmm.
And then some arrow function. And then we need to do something in it. So it must return a promise object. So that's what we're doing, right? And then it must resolve itself in 2 seconds. So you need a timeout, I guess.
Yeah.
Yeah. So we can do set timeout. And we have some function here. And then 2 seconds is 2000 milliseconds.
Yeah.
And then it must provide hello world in the data. So we need to resolve here. Okay. Oops, I don't want to save this. So did we do what is expected from us? We need to return a promise object. Yeah, we're doing that. And then we need to resolve ourselves in 2 seconds. You need to provide hello world in the data. Okay, let's run it. Failed. Data is not hello world. Oh,
You use capital for it.
It needs to be, I think, lowercase. Try again. Okay, so you mentioned.
For me.
Yeah.
Yeah, sorry, but for me, I was getting it's failed, and then after 2 seconds, I will get the hello world and it's successful. So for some reason, it was like failing at first, and then it would give me the successful message, but I didn't know why that was happening. And also the other thing that in this link, they are using the old way of defining the function. So it's like a little bit more messy than using the arrow function.
So
it was, for me, it was confusing why they are using that, and like I understand every step in the previous link for the practice. It was much easier to follow with the arrow function. So I just like this one confused me a lot as a practice, and the previous one was so perfect, so clear. So I don't know if someone else had a problem with that, but for me this one was confusing.
So this is using, let's say, the older syntax, right? Using anonymous functions. But basically it's the same thing. Is that what you mean? What they used?
Yes, yes.
Okay. So does this answer your question, or is there more?
Yeah, for me it's clear. It's okay. I do understand the process. I just thought like the link, and they don't give you much answer when you have error. They don't point out the error, so it's like I don't know what I need to fix in my code. And the other link was like give you where is the error or whatever. So it was better to practice on. So that was my point, like why it was like that, and why we have two different I don't know, two different links with different I don't know, syntax and different level of giving us the error. Like it's confusing because we are just learning about the promises. So we should not get confused or get two sources with different way of showing the material. I don't know. Like that was confusing.
Right. Well, I mean, JavaScript has a long history, and you find all the syntax mixed with new syntax, and that's just the way it is, I guess. So we're trying to concentrate in Hack Your Future here in the curriculum on the latest stuff.
Yeah, so we should not have this link anymore, I think. Or like give us another link, I don't know.
Okay. Yeah, so we need to take that up with Rob because he organizes the links to the.
Because if you try to go to the previous, you can see how they wrote the code while they were like describing it. Just go previous one, go to the 717.
Okay.
From the arrow.
Where's the button?
Yeah, from the arrow above.
No,
not from here.
This one? Oh, here. Yeah.
Yes,
okay.
yes.
Yeah, let's move away.
So you can see how they use it. It's like why we are using this now, and like .then and still function data, blah blah blah. So it's like a bit confusing and more writing and.
Okay, so they split it up, right? They saved the promise in a variable and then did this. Okay. Yeah, that's another way of doing it. So basically, this is the promise is saved in a variable, and then you can use the variable, which represents the promise, and then use the then on that.
Yeah.
Well, that's just another way of doing it. Okay. But you found this confusing.
But which syntax we should use? Should we always give a name for our promise, or should we only do return new promise? Because also in the cat code we only did return new promise. We didn't
because that is where we define the function that returns a promise. So, here. What was it? Here. We define the function which returns a promise.
Yeah.
And that's different from the code that we see here.
Yeah.
Here we don't have a function. We just create a promise directly. And
yes, but inside the exercise there is a function which is job. So inside it I can do the return immediately.
Yeah.
Yeah. I see. Okay.
Yeah.
Okay. Thank you.
Yeah. Okay. Where were we? Okay, Chalar. So you came across some resource, and I think that was a fairly old resource, because I would say this. Oops. I think you can do this so I'm using Markdown here to create this file, and I would replace this with async and await. So generators was a way in JavaScript. Get rid of this. In older version of JavaScript, to make something similar to async and await. Async and await is a fairly recent addition to JavaScript, as I mentioned earlier. And before we had that, to make your code look like synchronous code, there were some hacks that you could use generators to do that. But now that we have async and await, generators are really not used anymore for that purpose. And actually, I don't ever use generators in my normal code. I don't have a need for them.
Okay, so I understand we will not use generators, and we will learn async await for the next weeks, right?
Yeah,
okay.
That's correct.
I was a bit confused about this concept, so I need to ask this one.
Yeah. So,
okay, thank you.
Yeah. My question, which way is better, async or returning a promise? In case we need to fetch. Okay. Can you explain, Abdurrahman, what you mean with better async? What do you mean? I'm not quite sure if I understand the question.
It's not here, I think. It is not here.
Oh, okay. Then perhaps we should skip the question. Unless somebody else also has this question? If not, I'm going to move on to the next question in view of time. Said, are you there, Said?
Yeah, here.
Okay, let me just go back to, yeah, okay. So, is there a way to pass multiple parameters in promises rather than putting them in an array and passing it as a single parameter? So, what do you mean with passing multiple parameters in promises?
So when we chain the promises, we return the result value, right?
Mm-hmm.
So it has to be single parameter. So, but I want to like store two things and send them to the other function in the chain and do operations with both of them. Okay. I can put them in an array and send it as a single parameter, but
okay. So basically, this is perhaps not so much a question about promises, but about functions. A function can have only one return value. Yeah?
Yes.
But a function can return also an object, like an array or a JavaScript object. You can pass multiple parameters in the function header, or when you call a function, you can pass multiple parameters, but you can only return one value.
Okay, so they are the same as function, you know, same.
The same principle as function, because ultimately they are functions.
Okay.
Yeah.
Thank you.
Okay. Hello, I don't still get what the best practice to call promises. Should we call them after it's created or later on? And how should we organize our code in a professional way? Mustafa, can you elaborate on your question, perhaps?
I think I get it from the example that we have done with the cal walk. So yeah, I think it's obvious now for me.
Okay, well, that was my hope, actually.
Oh, yeah. Yeah. So thank you so much.
Okay. Okay, and then Lydia, your question about the example 3 or exercise 3 from the homework, right?
Yes, but mainly I want to know the what we will get with promise. If it will be the end, it will be solved or rejected, right?
Yeah.
So if it will reject it, it will not complete things. I think you gave this example with promise solve.
Mm-hmm. Okay, let's take this example. Let's say we fire a bullet to hit a target. Yeah. Now, when that target is a piece of paper, that will not stop the bullet, right? The bullet will go through the piece of paper and continue its travel.
Yes.
Yeah? So suppose we want to be notified with a promise when that bullet hits the piece of paper. Yeah. When the paper is hit, the promise is resolved, but the bullet continues. So if you want to stop the bullet, you have to replace the piece of paper by a brick wall. That will stop the bullet.
Ah, okay.
Yeah?
Yeah.
So let me show that here. Of course, I have an example here. Here I have a function called fire bullet. You see, it returns a new promise. That bullet travels. It travels a distance. And we have a function here called fly, for the bullet to fly. And in that function, we increase the distance by 1. Every time this function is called, it increases the distance by 1. And then we console log the distance over here. Yeah, and then we set a timeout. Yeah, and if the distance is 10, we resolve the promise. Yeah, we assume that the target is 10 positions or 10 whatever, 10 units of distance away from the place where the bullet is fired. Yeah, and then when it reaches that distance, the target is hit. Yeah, But if the distance is not 10, not yet 10, we'll fly again. Yeah, and we'll take 200 milliseconds for each step that the bullet travels to travel. And then, similar to what we did in the catwalk, we need to kickstart this function. So, and now we're going to use that function, fire bullet. Then, when the problem is resolved, we say resolved message, and otherwise, if there's an error, we reject it. Okay, I'll give you. Well, let's first run the code and see what happens. So I'll open a new terminal, and this is called bullet, right? So let's clear the screen. Well, actually, let's increase the width here. So note bullet. Okay. So this is. Oh, let's stop this. So the bullet was the target was hit after 10 steps or 11 steps in this case. But the bullet. Apparently the target was a piece of paper because the bullet continues to travel. Yeah, and there's no way that I can make this promise over here. I cannot stop the bullet here. So if you want to stop the bullet or the promise from continuing, or the timeout from continuing, you have to stop the flying here. You should not call fly again. So I could place a return statement here, so that this next fly will never be executed when the promise is resolved.
Oh, okay.
Yeah, so now it becomes a brick wall. Now my target is a brick wall.
Yeah, I thought that too. I forgot to put return somewhere. Thank you.
Yeah. So in the dice's example, we said we insist that the dice continues to roll when it rolls off the table, because there's no brick wall to stop the dice. Yeah.
Yes, fine. Yeah, thank you. Actually, I was really confused with this example from even cluster 3, and now, so I said no, I should ask now. Thank you.
Okay. Is this also clear for other people?
Yes. Can I ask a question also?
Sure.
For Mark?
Yeah.
But with the catch thing, if there is a then afterwards, it will continue, right? If you resolve a reject with a catch, any then afterwards will just execute again. This was a bit puzzling to me because I expected once it's catched, everything would be ignored afterwards, but it just resumes the then statements afterwards.
That's correct, and we can come back to that in another question from Daniel, I think, where we can address it. So this was Lydia. Then we have Alexander. With asynchronous, we can keep the code running. Are the situations where the code in some point will rely on when the code in some point will rely on the asynchronous return? If so, how can we avoid blocking then? Okay. So at some point, if the asynchronous event takes a long time, and we can't continue without having that result, I think that's what you're referring to, right, Alexander?
Yeah, exactly.
Then, well, basically we can't continue. I mean, if we don't get a result, we don't get a result. But that doesn't mean we are blocking anything. We can still do other things. We can still let the cat walk on the screen or render a GIF or whatever. But we can't continue with what we were supposed to do. It doesn't block anything. Maybe it blocks logically. It blocks the user. It blocks the user from continuing what he intends to do. But it doesn't block the browser. Does that make sense?
Yeah, but then okay.
The user is blocked.
So the other functions will still work. Like he can still press buttons, and
yeah, because
the event listener will still working on the website, but this particular element will not be work.
Yeah. So the only when the promise is resolved or the asynchronous event actually happens, then we can continue that part of the code. Yeah, but while we are waiting for that to happen, whether it happens or not, we can still do other things.
Okay, but there is if we are writing the code in a way that's it's a synchronous code, and one of these synchronous parts is relying on asynchronous promise or waiting. So what will happen for the next one?
Well, it's waiting, but while it's waiting, it's not blocking, because it's waiting by means either of a promise or a callback, and the callback or the promise will only execute when the promise is resolved or when the event happens. If the event doesn't happen, well, we can still do other things.
Okay.
Can I add a comment about what Alex is asking about?
Yeah, sure.
Yeah, what if the main purpose of our website is to get a data from a database and to play it for the user when he clicks on a certain button? So the main purpose is for the user to see that data, and if the promise didn't resolve, we didn't get that data, so we cannot show the user anything. So basically, he will not go and click on another button, so he don't care that the browser is not blocked. For him, it's blocking because he cannot get the data, he cannot do what he wants. So what we should do in this situation?
Yeah, it's like installing a new program, so he should wait, I think.
So basically, you should inform the user of what's happening or what's not happening in this case. Yeah. So you could say to the user, if you, let's say you expect a response, you should probably either you get the promise is rejected by the database or by the database software. It says that well, I can't do this, and then you should inform the user with a message on the screen that something went wrong. And you need to inform the user that there is a problem.
That's it. We don't do anything else.
You should always inform the user of what's happening. Also, when there are errors.
You need to wait because we still need, I don't know, 10 seconds, 8 seconds, whatever, like
yes,
to get
so for
the
instance,
information, or we couldn't code it, so it's an error. Something.
You should always inform the user of what's happening, so that the user should be looking at the screen and then and be confused of what's happening. Always inform the user. Also, when there are issues, when there are problems, when a network request fails or whatever, tell the user. And then don't tell the user in the console log, because the user will not look at the console and run with the page.
Not, yeah.
Yeah?
yeah,
okay.
Sure, okay.
Okay, good.
Yeah, thanks.
Okay, my question, why you use promise? Okay, give an example of a change from, I think, George, didn't we already cover this?
Yes, I think I got good answers for my questions, and everything is clear now.
Okay. Then the second question, use async and await will cancel the role of promise and callback. Well, not async and await is only a way, an alternative way to consume a promise. So rather than using then and catch, you can use async and await.
Okay, thank you.
Yeah. Hey, that's the last question.
I hate to say this, but I think my question wasn't there.
Oh, yeah, okay. me neither.
Oh, okay. Let's see. Did I? Where did it go then? Let me see. So you're Daniel, right? Daniel.
Wait, there are two Daniel. So yeah. Maybe that's the reason why.
Yeah. So I thought it was I had it, but if not, then we're going to look at your question. I'm going to paste it in from here. Let's see, Daniel. Yeah, when a promise is refused. I think for one or another reason, it got lost. Daniel Wang, right?
Yeah, exactly.
Q1. So when a promise is refused, could the promise loop? Here, I wonder why this was gone missing, but because I had it in here. So when a promise is refused, could the promise loop itself until it is resolved? What if a promise couldn't be resolved forever? Okay, so let's first look at a scenario where this might happen. So the most likely scenario that comes to my mind is when you make a network request. Yeah, and maybe you have a bad network, or maybe on a mobile phone, unreliable. So what would you do in that case in your application? Well, I think that depends a bit. If you, for a user application, maybe on a mobile phone, you probably, I would say, you probably would inform the user, hey, I didn't get a response. Do you want to retry?
Okay.
You leave it up to the user. Yeah, because if you try in a loop, maybe you will block the application for a minute and then come back to the user. Hey, I've tried 6 times, but it failed. And all the time the user is looking at the screen and thinks, hey, what's happening? Yeah. Now it may be a different situation when you have let's say, an unmanned explorer going to Mars that needs to communicate with Earth. There you want to retry as hell to establish communication. Yeah?
Yeah.
So that's a completely different situation.
Yeah, so you would say always provide when a promise is like rejected, always provide a limited steps of solution to the users and let them decide if they're going to reload or anything instead of just looping it forever.
Exactly, and it also depends on, will retrying actually help? Is there a good chance that a retry will be successful?
Okay.
Yeah, because for instance, if there's a database failure or whatever, I don't know, then retrying may not make any sense because it will not work the next time. After 20 milliseconds, there will still be an error. So you need to ask yourself, will retry actually help? Will it be helpful? Is there a good chance that it will succeed the next time?
Yeah. Thank you.
Yeah, and what if a promise couldn't be resolved forever? Well, forever is a long time. Right?
Yeah.
So maybe, for instance, let's say you're making a request and you don't want to let the user wait forever. What you could do is you could create a watchdog timer and say, okay, if this promise is not, or if this network request is not fulfilled in, let's say, 2 seconds, my timeout will fire and I will reject the promise.
Okay.
Yeah? Okay. That's good enough?
Yeah, thank you. Yeah, that addresses my question. And I think we also have Osama, and then that's it.
Osama, let's see. Okay, yeah. I don't know what happened here. Okay. Well, that's good because we still have time. Osama, and that was Basboon.
Right.
Yeah. Osama. And then this would be Q2. Set timeout with promises to make sure. Oh, wait a minute. Is it mandatory? I'm missing something here. Is it mandatory to use set timeout with promises to make sure that we are settling asynchronously? Well, settling asynchronously is not a goal in itself. It's the fact of life that we have to deal with. We have to deal with an asynchronous world. And so, for instance, as I mentioned, network requests. If you make a network request from a web application, then it goes up to the internet to make contact with some server somewhere, and then sometime later the result comes back. That is asynchronous. It's a fact of life, right? So promises are a way to deal with things that happen sometime later, asynchronously. We are using here in this Q&A and in week 1, we're using set timeout as a poor man's example of creating asynchronous. I can't pronounce the word. To use asynchronous events, right? We're introducing that here to make the concept of asynchronous code to demonstrate that. Yeah, but so again, settling things asynchronously is not a goal in itself. We use promises to deal with that. We deal with asynchronous code. So no, set timeout is not necessary to deal with asynchronous code. Asynchronous code is a necessity to deal with things like network requests, I/O requests, database requests, whatever happens asynchronously.
Yeah, actually, I asked this question because while I was studying in one of the materials, they said it's like let's use set timeout just to make sure it's running asynchronously, and we were using promises. And for that, I just asked this question.
Okay.
Yeah, I know promises it's to dealing with the asynchronous execution, but I wondering why they said to make sure we have used set timeout.
Yeah, sometimes you can use a set timeout and then specify as the timeout value 0. Yeah, because for some reason you want the code, you want some code to finish before it gets to whatever you do in a set timeout 0. Yeah. So
just to make sure it's going to be in the callback queue.
Exactly. So you want the current synchronous code to finish before the thing that you specify in the timeout runs. And that's why you use set timeout, 0 to make sure it happens when the current code has been finished running.
Okay.
Yeah?
Yeah.
Okay, in chaining multiple promises, is the execution of multiple promises going to be sync? So no. Okay, I think we already saw that. For instance, do we still have it over here? So we saw that this code runs, let's see, it runs once for the synchronous code here, then it runs a second time for this one, it runs a third time for this one, a fourth time, and a fifth time. So every promise here, and then also returns a promise, is a new a micro task, which is put on the micro task queue. Yeah, so it doesn't run synchronously. It's a micro task that is queued on the micro task queue, and then whenever the JavaScript engine has finished running the current code, it will go to the micro task queue first and get the next event from there. Okay, so no, it doesn't run this code synchronously.
So it doesn't depend if the Zen1 function and Zen2 function has need different time to be executed. Like if the Zen2 finished before the Zen1, would we get the result from Zen2 or not? It's synchronous there.
No, this Zen2 only functions when this because it's chained, this then function returns a promise. Yeah, but only when this code has been executed. Yeah, so the promise from this set function can only be executed when this code has been executed. Maybe you should...
Yeah, sure. No, yeah.
Yeah?
I think I get a little bit confused with promise all when we have different promises.
Yeah.
And it doesn't need to be like, if we put like promise 1, promise 2, promise 3 in the array, that's not necessarily how we will get them out, the result of them. Because promise 2 might finish before promise 1, right?
That's right, yeah. So here, so here we have, again, we have these 3 promises, and what happens when we call this function here, the wait function is called. Yeah, and when you call this wait function, it immediately runs this set timeout code. So when you call the function, the timeout is already going to run. Same for here. So basically, when you define an array like this, where you call the wait function 3 times, there are now 3 timers running.
Yeah.
Yeah. It's own and whether you call this or not, the timers are running when line 12 is executed. It's only here where you are going to look at the results of the promises. Yeah.
Yeah.
And let's see. We could add here another. We could modify this a bit. We could say message. So okay, and then we resolve the message. And we're not going to test for success. We're just going to do this. Okay, so we have this function wait. We have a message parameter and a delay parameter. And then when the timeout fires, we're just going to resolve and pass the message back. And now we can do this. Let's say we want to have a message first. And then we say, okay, delay 10 seconds, milliseconds. Second, and delay 200 milliseconds, or yeah, 200 milliseconds. Yeah, and then a third promise, and we say third, and we're going to delay 100 milliseconds. Yeah, do you understand what I'm doing here?
Yeah.
Okay. So now, what will we see here? What will we see? Well, we're not rejecting, right? So we can actually get rid of this to make it simpler. So what will we see?
We should have like first, third, second.
Okay. What in promise? Yeah. Oh, let's get rid of this code because that's confusing now. Oh. So you can see here the second promise is resolved after 200 milliseconds, but we still get first, second, and third here.
So it waited until all the promises was finished, and then it gives me the result.
Yeah, and it gives you the results in the order of the array. See, the first one, second one, and the third one.
Yeah.
Sorry, we got this because we have array, right? So it's fitting the results in the array. So it's going to be always in this order, even if we change the delay.
that is the definition of promise all. You pass if you look up the documentation for promise all, you pass an array of promises, and the results are in the same order as the input array.
But if we put a console log inside the function wait to ask the message, then we can see the order.
Let's do that. Yeah. Okay. So let's say that's a good suggestion. Okay. Oh. Resolving first, resolving third, resolving second, but still get the results in the same order as the array. That's how promise all is designed to work.
Sorry, this resolving ordering, this is the same ordering that we have inside the callback queue, right? Like first, third, second, and then the promise all is fitting everywhere in the correct place inside the array.
In the event queue, this is the order that the events are in the event queue. Is the first, then the third, and then the second.
Yeah.
Yeah. But the way promise all works is it returns the results in the same order as in the array. Otherwise, it becomes unpredictable. Yeah, because you can't associate which result belongs to which promise. If promise all didn't do that. So you now can always be assured that the first result is from the first promise in the array.
Yeah, I got you.
Yeah.
Yes, thank you.
Are there any more questions?
Just one more question. So during our coding, do we need to pay attention to the order in the queue for the resolving promises, or just we pay attention to the order of the array of the promises we are getting and we work with that?
Yeah, because you can't see the queue, you can't influence the queue. The only thing that you can work with is how it has an effect on your JavaScript.
Yeah, I know that, but I mean, in our thinking, should we pay attention to the queue or not? As a concept, I mean.
Yeah. I'm just thinking about it. I have to think about the queue, actually.
Yeah.
Because I don't need to think about the queue. Because I only need to deal with code, not how it works internally.
So it will never affect our work in any situation later on when we are fetching data from somewhere, or like doing multiple promises in the database. It will not affect the order of the queue. It will not affect our work.
No, but you need to understand
the concept of it.
Concept, and also if you run into problems, you need to know where to look, and you need to have an understanding of a bit of how it works under the hood in order to debug your code.
Yeah, sure. Yeah. Okay, thank you.
Okay. Did I miss out any other questions? No? Do you have any other questions?
No, thanks.
No.
No? Was it useful?
Yeah, so much.
Yeah, so much.
Yes, very.
Yeah, I think I need to have a look about the walking cat, like, very carefully. Yeah, that one is pretty useful.
Yeah, it's a good
At the beginning
example.
of the session, you mentioned something else that you would like to present to us related to the event loop and something else.
Yeah.
If you still have time.
Yes. Let me remember.
The beginning of Q&A session, the comments.
Yeah, what was it? This was the So what happens after catch? I think.
Yeah, I mentioned that.
What happens after catch?
Yeah, because generally the recommendation is to use the catch at the end, because if an error happens, it will ignore all the dents and just go to the last catch. But if you put a catch somewhere in between, there are dents afterwards. Then after the catch resolves the reject, it then picks up and continues with the other dents.
Yeah. Okay.
So that's that's a nice thing to keep in mind when you.
So I have an example that we can use over here. So here I have a code which is simulating network requests, fetch requests. So it's a topic for next week, but this is just a simulation of a fetch request which returns a promise. So I'm fetching from this URL, from this dummy URL. Yeah, and then so this would be a network request, and then sometime later I get a response. And I'm console logging the response, and then I'm doing another fetch request. So this fetch request is depending on the response from the first request, because this first request returns an object, and that object contains a property which has the URL for the next request. Yeah, and then when this fetch is done, I'm going to do, I'm just console logging here the response. Yeah, and if there's an error, I'll log the error. Here I'm using another file which contains the code for fetch. Yeah, and you will learn about require and the syntax in the Node module later. But for now, this is what the fetch looks like. So I have some data here. I'm using an index variable, and perhaps it's better to use that index variable over here. Okay, so I have here a simulated response. So the first time I make a fetch request, it's going to return this object as a response. So this object contains a property. Let's say this is a page number 1 of some application which has pages, a paged application. It returns some items, which is sort of like the payload of the data. It could be anything, could be products or whatever. In this case, it's just numbers, and it returns a property which is a URL to fetch the next page. Yeah, and then so there are now. This is commented out, so let's skip this for now. So I can make 2 requests here, and it will first return this object, and the second time it will return this object. And this variable is used to indicate which of the elements the function should return. So this is what the fetch function looks like. Fetch. Yeah. So it takes a URL as a parameter, and then it console logs that URL to the console. Yeah. Then it returns a new promise with resolve and reject, and then in the timeout, this is just a simulation, remember, it takes the index, which is initially 0, and it returns the first element of the simulated response array, and resolves and passes that to resolve as the resolved value of this promise. And it takes 100 milliseconds, so it simulates a network request that takes 100 milliseconds to come back to the caller. And then I'm exporting this function. Again, this is syntax that you will learn in the Node module. So here's the client again. So if I run this function, let's first see what happens when I run this function. Okay. And this is called client. Okay, let's make this a bit bigger. Maybe should run it again so that you can see all the output. Okay, this is the first request, and this is the first response. And you can see that this response includes this next URL property, which is used for the next request. Yeah. And then this is the second response, and it returns also a URL for the first page. So let's again look at the code. So here is the first request, which returns this response. And then from this response, so we console log that response, and from that response we take the next URL property to make a next request. Yeah, and then we return the promise from this fetch, and we then get the response from that second fetch, and we console log it here. Yeah, does it make sense? Okay.
Yeah.
So now let's go back to our fetch function, and now you can see we can also simulate a failed request. So now when we ask for the second page, we will fail because our code here looks for this property. If I remove the commenting out, you see if the response property here is fail, if from the simulated response is fail, we're going to reject the promise. We're going to say it's failed, and then we return. So we don't resolve, we just return. Lydia, this is the brick wall, right? This is the brick wall which stops the promise.
Yes.
Yeah? Okay. So let's try again. What does it say? See? It failed. Now suppose when it fails, and why does it fail, or where does it fail? It fails here in the catch, right? That's where it's printed. That's what prints the failed message. Now, what we could do in this case, we could say, okay, we could say try again. So we could say, okay, we know we got this error, but we're going to try again. And then we can say return. Well, this is the response, right? Now can we do that? Here I have an issue because I don't have available in the catch. Wait a minute. I need to communicate back from here what the URL is. So what I can do is I can create an object. So instead of rejecting with just an error, I return with an object because I want the client to be able to do the request again, and therefore I need to communicate back to the client in the catch handler what the URL is. So in the client, what I can do now, it's not an error, it's the response object. I could say response. And now it's the response. Did I call it error? I can't remember.
Yeah.
Error. I called it error. Yeah. But I can also now say, okay, let's return now. Let's try and try again to see if we can make this work. So return fetch and then URL. Now this doesn't, and then I can use, I guess this. So now I'm using the catch handler to try again. And it returns a new promise. It returns the fetch from this URL. Now this doesn't completely work correctly because I now get probably the third page rather than the second page. But it's just a simulation. So let's try and run this. Oh, wait a minute. Fetch failed, and then I have an unhandled promise.
Yeah, it's the response.url. I think you just typed the URL. So it's
oh, okay.
it's just a typing error, I think.
Did I? Oh, okay.
The last fetch.
Yeah. Thank you. Okay. Oh, okay. I do get paid. So basically, what I've done is the second attempt failed, because I made it fail. And then I'm retrying. So I'm trying to fix the error that I got in the catch handler. Yeah, and in the second attempt, it succeeded. So basically, this is sort of like the retrying thing, right? I've retried. The first network request failed. I've retried, and the second one was successful. Okay. So does that make sense? I mean, the catch also returns a promise. And in this case, I'm returning a promise that tries to correct the error.
Yeah, great example. Thanks.
Yeah. Any more questions? I'll share
So
this
this is
code
the
with
practical
you.
way to write promises in separate file and then to use it in another, like in big projects.
Now, this is just a way of organizing your code. When you have code when your code becomes larger, in this case, I placed it in a separate file because I wanted to hide the details of what's happening. I showed it once, but now that we've shown what it looks like, for this code, it's not really important how the function works or how it's implemented. Let's put it that way. So that's why I've hidden it in another file. It's a matter of organizing your code. You want to organize your code into separate files. If your code becomes larger, you want to organize it in separate files so that you can work on the code that you're focusing on, so that you don't get detracted by all the other code which is not relevant for what you're doing at this point in time. So you organize your code into separate files. And I think you guys have done that in the browser project. Right?
Yeah, exactly.
Yeah, it's a way of managing a larger complex applications. And you used import for that and export, I think, or what is it?
Yeah.
And here, because I'm using Node and I'm using require and module exports. It's another way of doing it in Node.
Yeah.
Any more questions? It's almost 3 o'clock, and Chebe is knocking on the door, on my door here. How's it going? So I'll share this repo with you guys, and also we'll paste the recording or share the recording in the Slack channel for if you want to review something.
Yeah, thanks.
So if there are no more questions, then good luck with the homework, and we'll meet again next week.
Yeah, thanks. It was a very useful session.
Okay,
Thank you.
Thank you, Jim.
Okay.
Okay.
Thank you, guys.
Bye-bye.
Thank you.
Yeah.
Thank
Bye.
you. Have a nice day.
Bye-bye.
Bye.
Bye.